Hello. I'm going to talk to you about the journey that we took to provision big data applications and big data clusters with Ansible. Some specifics and also some things that we've learned along the way that you might find useful. So I started working in IT in about 2007. In tech support, I then became a systems administrator, did that for about six years. And I am currently IT operations manager at Bigstep. I'm always passionate about improvement, about testing and playing with new applications. I totally dislike repetitive tasks. This is actually one of the reasons that we chose Ansible and why we automate all our things. Bigstep is the company that I work for is a high-performance bare metal cloud, meaning that instead of actually deploying virtual machines, we deploy physical servers in something like 2 minutes, fully booted up into the operating system. Each server has 40 gigabytes aggregated network. We have 4 10 gigabytes ports, and you can basically configure them however you like. You can aggregate multiple ports into a single teaming or bonding. You can have your own local area network for your services to talk between each other. In order to provision nodes this fast, we decided to have a distributed all SSD and also some HD storage. From this storage infrastructure, we boot up the nodes via different network protocols like iSCSI. And on top of this cloud platform, we automatically provision different types of big data applications. For Hadoop, we provide Cloudera, MapR, and Hortonworks. We also have others like Elasticsearch or Couchbase datasets and so on. This is fully automatic. You just click one button, select the number of nodes and the type of servers you would like, and you can have a cluster up and running in a couple of minutes. When we started, of course, we started building a prototype for our application and for our application infrastructure. This was, being a prototype, was not redundant. We didn't have high availability, and a lot of things could happen. And when we started thinking about how we would like to have our application to be highly available, we thought that the best way we could assist scaling up and down our own infrastructure is to use automation, and we decided to go with Ansible. So this is something, just a little part of our own infrastructure. Of course, you have some load balancers, you have backend servers, app servers, SQL databases, and other different services that are required to run our application. So we started and we automated all this process. We just have the operating system, and then using Ansible, we automatically configure everything that you see in there. So the first, having this automation in place gave us the flexibility to easily scale and to have multiple points of presence. So for instance, the latest addition was the Chicago point of presence, and by having our playbooks ready, we were able to provision our own application with configuration files and then just deploying everything in less than a day. So the first version, we had a Git repository that had multiple roles, about 15, and one big role, common role, we called it, that could configure all the things on multiple operating systems. That common role works on CentOS and Debian-based distributions as well. We could have then multiple environments. So prior to getting to production, we can just have a staging inventory with all the servers and all the specific variables for those servers, and we can easily run the same thing on that environment. And this actually helps a lot because you can test prior to getting something into production. About a year ago, we started rewriting everything that we had over here, and we separated that playbook into two separate playbooks. We now have a bunch of more roles than before, and we got rid of that common role that did a lot of things. We separated every role you see there right now has its own Git repository, so it can be used by anyone in the company. So let's say a developer wants to install Elasticsearch on his virtual machine for some tests or something, he can just pick up that role and he can play with, easily install Elasticsearch. And then each role is a submodule of the two playbooks you see there. We split into two because there were two parts that we considered important. There was a part that every server should have, I don't know, antivirus, monitoring agents, and I don't know, different repositories. So that is done in the playbook infrastructure. And then we have the BSI playbook that takes care of actually deploying all the necessary parts that our application requires. Again, we can have multiple environments. We can have a production, we have an integration, we can have a staging environment, and we can easily deploy using the same tasks and the same roles into all of those environments. We can even deploy, we use Vagrant, we spawn up a couple of VMs and then just run the playbook, and we have the application up and running in, I don't know, something like 30, 40 minutes. So after having the first playbook that I talked about earlier, we decided why not do the same thing for customers and deploy applications, big data applications in the same way using Ansible. So we talked to developers about this and we gave them a short presentation, and surely within a week they were able to have something working inside the application and deploying some Hadoop nodes. So our application is structured into multiple drivers. We have storage drivers, switch drivers, operating system drivers, and some app drivers. Since it's not always possible to do everything with Ansible, although it's easy to write some new modules in Python and integrate them into your playbooks and tasks, we decided to also have an API driver that talks directly to the specific applications. So for instance, we have an API driver for Cloudera, and it talks directly with Cloudera and gets health information, the number of resources available, versions of the cluster, but also takes care of managing the cluster in scaling it up and down as it sees necessary based on the client's requirements, to assign different roles to each node. I don't know, for example, you add a new node and you want to store data on that node. Through the API driver, we talk to Cloudera and attribute the data node role to that specific instance, that specific server. For instance, an Elasticsearch in our diagram looks something like this. On the left-hand side, you have two instance arrays. An instance array represents a collection of servers that typically have the same role in a cluster. In this case, we have master nodes and slave nodes. And then once you click on instance array, you have a special tab where you can see different information about the cluster. You can see some health information and some resource consumption on that cluster that is our application pulls the cluster through its API and gets all that information back to the diagram. This is what it looks like in, Ansible. Those are the names of each task that run on the nodes. The playbooks look something like this. It's split into 3 different rows. A common row that adds things like the Elasticsearch repository and installs different other dependencies. And then we have 2 separate rows, one that is run on the master nodes and the other on the data nodes. The same thing for Cloudera. You have 2 instance arrays. You have the head nodes, which typically hold the metadata and other key components of the cluster. And then you have the data nodes, which store all the data and expose HDFS and other services as well. You have the same, you have the information about your cluster. You can actually access Cloudera Manager. You have the URL, the username and password. And that is translated when we deploy into something like this. As I've said, Cloudera is a little bit more complicated to deploy, so we have a special API driver for that adds the nodes through the CDH API, assigns different roles, sets up Kerberos principles and encryption, starts the services, and also through the API based on the resources available on the cluster, we calculate default values for configuring different services like Yarn. Another thing that's important is when someone wants to scale down the cluster, we first evict the data, make sure that there is no data on the node that is being removed. Afterwards, we remove that node from the cluster so it's entirely safe. So why did we choose Ansible again? Some other key points are the fact that it's agentless, so you don't need to run anything on the nodes that you are configuring. It uses standard SSH, and that's really important. It has a simple format, a simple YAML format, and it has a very small learning curve. Like I said before, in about a week, our developers already started playing with it. You can run the same thing over and over again and you get the same result. A couple of important things and gotchas. You can have sort of automatic documentation just by using a name tag for each task you run. Most people don't really like writing documentation, so this is an easy way to have something and to make it easily available and understandable to other colleagues. You can check whatever you are running, whether it's correct or not, by using syntax check. Also, you can do a dry run by using the check parameter. And if you are changing configuration files and you see that there are differences, you can just use the diff and automatically it will show the differences between what you have in your Ansible task and what's in production. For storing secure passwords and other things, you can use Ansible Vault. You don't really want to store passwords in Git repos. So you can just encrypt the YAML files using the Ansible Vault and store them along with your playbook and have the password separately on your machine. Tags are also very useful. Let's say that you have a big playbook like you've seen ours, and you just want to run some firewall changes. You can attribute the firewall tag to the firewall role and then just execute that piece of only those tasks that you have right there. If something fails, you can just pick up where you left off using the retry parameter, or you can start at a specific task by naming the task itself. If you want to do upgrades, for instance, and you want to only upgrade half of your hosts, you can use the limit parameter and you can specify, I don't know, just web servers *1 or something like that. You can also limit by the group. Maybe you want to run on a single group of servers, not all the servers that you have in all groups. If you run in integration on different environments, you can use a time parameter in front of your Ansible playbook, and you can see how long it's going to take to actually deploy the same thing in production. And the documentation is really good, self-explanatory, and it gets updated constantly. I think right now Ansible is about to release version 2.2, and they already have the documentation in place for the new changes. Some things that we have under development, we have our own ChatOps bot set up in Slack, and we would like to integrate that better with Ansible in order to do things like deploy an integration so that development can faster push changes there, maybe even into production at some point. Maybe integrate with Rundeck to have some tracking to see who is running what. We are planning on releasing our own Ansible module in order to provision or expand clusters through Ansible. So you could just call an Ansible module and say you want 2 nodes more or something like that, and you can scale that way as well. We already have a part of this of doing major app upgrades. So let's say you're going from Cloudera version 5.3 to version 5.6. We want to be able to provide this option to our customers because I know it's important to be on the latest version and maybe use the latest features that are available in that latest version. So we want to have a system in which we do snapshots, we upgrade, and if anything fails, we can easily then just roll back to the previous version. Thank you very much. Don't forget, go bare metal. Do you have any questions?
You know, well, it's not, oh yeah, sorry. You know, Amazon is providing now, you know, cloud services, Google, Microsoft. So does Bigstep compete on the same market? I mean, do you target the same customers as Amazon, Google, and other providers do? What is the main advantage of the bare metal or full metal over the cloud-based or virtualized platforms?
Okay. Well, typically virtualization adds an overhead. So even though you have the same number of CPUs as you would have in a bare metal server, you still have some performance penalty. So this is actually the key thing about us. By using bare metal, you get the full server. You can make use of all the resources. Thank you.